Greetings, everybody. Let's do this problem that's about finding the slope of a curve at a specific point, and then with that, finding the equation of the tangent line at that point. Okay, so here's the question as you might see it on my math lab. I'll go straight to it. I'm going to show you my work down here, and I'll talk about it a little bit in reference to the question up there, and I'll say a little bit about the algebra that's involved. So first part I put is we need to find the derivative of that function. I guess that's misspeaking a little bit because actually this formula that was provided with the question tells us not the derivative, but it tells us directly the slope of the tangent line at the point that's given. Okay, the derivative is its own function that tells you the slope of the curve. All right, this tells you the slope of the tangent line at a specific point. What I do is I take that formula as it was given in the question, which you can see up there, and I let the number a be the x-coordinate of the point that I'm interested in, which in this case is 4. So it's going to be the limit as x goes to 4, f of x minus f of 4 over x minus 4. If I evaluate that, whatever I get from that tells me the slope of the tangent line at the point on the curve where x is 4. So this expression with reference to that function is what you see here. The 7 comes from what I get when I put 4 for x in that function, which is the square root of 49, or 7. Okay, so my task becomes to evaluate this limit. The way that this limit will need to be done is to first simplify it with a little bit of algebra. The reason we do that is if you try to evaluate this limit straight away as it is, you'll get 0 over 0, which tells us nothing about what the limit might actually be. Me putting this 4 in and getting 0 over 0 doesn't mean the limit doesn't exist. It doesn't tell me anything about what the answer is, no matter what, okay? So I will take this expression right there without the limit. I'm just doing algebra at this point. I'm not doing calculus. And I multiply it by the conjugate. That's how we handle these sorts of things when they have square roots in them. The conjugate takes this expression that contains the root 9x plus 13 minus 7, and just changes the sign there. And ultimately what I'm multiplying by here is 1, because I'm taking that and dividing it by itself. And that's 1, right? So I'm not really changing what I have. This just allows me to change the form of it. Now, as I multiply this by the conjugate top and bottom like that, the conjugate causes some canceling to happen, which simplifies it. I use FOIL multiplication, and I get root 9x plus 13 times itself is 9x plus 13. The 7 with the negative 7 cancels, and then negative 7 times 7 is 49. For this bottom part, I won't multiply it together, because that will just make it hard to cancel something that shows up in a minute. So I combine some terms right there. And I need to reduce this all the way that I can, or at least to the point where the 4 does not cause me 0 over 0. So I'll need to continue factoring this. I factor out the 9. That's how I get the x minus 4 duplicate, which those cancel, okay? And I get a 9 over root x plus 13 plus 7. Okay, so at that point it's simplified as much as I need to. I can then apply the limit to it. Which works out easily as 9 over 14. Okay? All right, so that number then is the slope of the curve, or the tangent line, however you want to say it, at the point I was given. All right, so now that we have that, we'll find the equation of the tangent line in 3 steps. First of all, step 1, I'll say the tangent line is a line, and so it has the equation that lines have, which is y equals mx plus p. My second step is that I know what the slope is supposed to be. I just figured that out. It's 9 over 14. So as a partial answer, I would say the equation of the tangent line is y is 9 over 14x plus b. B is this unknown constant left over there. Technically, it's the y-intercept of the line. But the way I'll find that is with this third step, that this tangent line is tangent to that curve at the point 4 for x, 7 for y. Okay, so what that means is that it has to contain that point. That point has to be on the line. So what that means is that it is fair and okay to let y be 7 and x be 4 and solve for b that way. That's what I do here, and I do a little arithmetic to come up with b is 31 over 7. So then that completes it. The equation of the tangent line is 9 over 14x plus 31 over 7. So you'll see answers consistent with all that up here. 9 over 14 is the slope. There's the equation of the tangent line that I just showed you. This first part is just asking you a little bit about the algebra, which I explained about that being the conjugate, and that's what you needed to multiply by. The last part is, can you choose the equation of the tangent line and the curve at the point that's given? And no matter what, they're going to have to blend together at the point of tangency because they have the same slope. I don't know that the graph is a big deal with this one, so I'll let you graph that any way that you want. But the impression I want to leave you with, I think, is the difference quotient. This thing, okay? This deal right here is called the difference quotient. And I think simplifying that is where most of the work ends up being.